Okay, so here are some notes on chapter 16, just some quick notes. The chapter is called More About Tests and Intervals, and really it's basically a review of everything that we've learned about so far. So I'm just going to go over the essentially big points in the chapter. So just some reminders about like what we're dealing with in this particular chapter and some of the this particular unit and some of the vocab. We've seen two different null hypotheses at this point, one for proportions and one for means, but they actually both mean the same thing. What it means is, so the null hypothesis typically means that no change has occurred. Okay? And then I want to make it clear, let's make a statement here that this is never shown to be true. Typically, this is a statement of the population mean. So that would be like the mu naught, or in our case, p naught that we've learned so far up to this point. Okay? And then the alternative hypothesis tries to claim that there has been a change. So this is a claim of an increase, decrease, or just change, right? And that would be different from. Increase and decrease would literally be greater than or less than. And let's make a note of this is what you're interested in showing. Okay, so we always want to show that the alternative hypothesis is the truth here. And then how do we actually do that? Well, in every situation, we calculate a test statistic, and then we calculate a p-value. So let's discuss our p-value here. The test statistic, let me just circle back. The test statistic is very important there because it determines the p-value. But for each test, we have a different test statistic. So for a 1-prop z-test, we would have had a z-score, and for a t-test, we would have had a t-score. So the p-value is actually a conditional probability. And it's the probability of getting, let's try to write this down, the probability of seeing results, let's call them as unusual or atypical as the observed H naught is assumed to be true. So if I could write that maybe in a sense that makes a little bit more, I don't think I mean that. I mean p-value is equal to the probability of seeing an observed statistical value given the null is true. So we basically assume, if I were to draw a little picture here, that the null hypothesis is true. So this would be either mu naught or, p naught, right? One of the two, depending on the kind of test that we're doing. And then let's say we were testing less than. Well, down here would be our test statistic, right? So this would be our x bar or the p hat from the sample. And this shaded area here is going to be my p-value. So it is literally the probability of seeing something further away from the mean than my sample data. Okay, so probability of seeing something further away from the mean than my sample data, which so that's just another definition of the p-value. So remember, my sample data is either x bar or p hat, right? It's the mean from the sample or it's the proportion from the sample, depending on, again, which test we are running here. I'm going to move to a new slide so that we can keep going. Okay, let's discuss how we conclude the test, right? The conclusion. I just moved the slide. Sorry, guys. For the test. Okay? So it doesn't matter which test it is, the p-value, the t-test or the one prop z-test, but we always compare the p-value, right? This is from the calculator, to the provided alpha level, and that's my significance level. And we have two options here. If the p-value is less than the alpha level, then we reject the null, and there is evidence of some change. I'm not going to say what direction because it depends on the alternative hypothesis. Okay? And then if the p-value is greater than or equal to the alpha level, we fail to reject the null, which means there is not evidence of change. I don't know why my pen does not like writing the word change. Okay? So they basically are saying here that if my p-value is really large, which means that my sample data is really close to my hypothesized data, then it's not basically far enough away to claim there is a change. So then we have two definitions here that come along with talking about our p-value. The first is referred to as statistical significance. And that is literally when my p-value is less than my alpha level. Okay, so if I get to the end of a hypothesis test and my p-value ends up being less than alpha, it is said that the results are statistically significant. And then practical significance is when the sample data, so when the results or the sample differ drastically from what we refer to as like the status quo, which is really just the population mean. So an example of this is like somebody predicts that the vote for a particular candidate is going to be 50%, but then when the votes are tallied, that candidate actually took home 80% of the vote. Like we can all see that there was an actual change there. We would perform a statistical test and see how tiny the p-value is, but most of us can declare a change just from looking at the two values. Okay, and then we have a final new concept here, and it is referred to as type 1 and 2 error. So I'm going to give the definition of the two, and then I'm going to try to give you a little example here. So type 1 error is when we reject the null, but the null was true. So remember, these are basically mistakes we could have made. They're errors. So I want you to be thinking like, oops, we made a mistake. That's what's happening here when we discuss type 1 and type 2 error. And I'm just going to put like a line here so that it separates the practical and statistical significance from this part. The second here is type 2 error. And the way that we deal with that is that's when we fail to reject the null, right? So there's only 2 conclusions to the test. Type 1 happens when we reject the null, but the mistake is that we rejected something that was actually true. And in type 2 error, we fail to reject the null, but the null was actually false. So we failed to reject, but we made a mistake there as well. So let's go and do my favorite example of this, which is jury decisions, right? So my favorite example is when the null hypothesis is that they're innocent, and the alternative hypothesis is that the person is guilty. So I love a good court drama, like Law & Order SVU is one of my favorite shows. I used to name my pets in college after the characters. So this to me is a good example, and most of us kind of understand what's going on in the court system. So a type 1 error here in context would be, remember, we're rejecting the null, which means that we would claim someone is guilty, but they're actually innocent. So this is like putting an innocent person into jail. And I love a good Netflix documentary as well. So this would be like Making a Murderer, where Stephen Avery was arrested and they did, and then he was found, like he was wrongfully accused. Okay, let's flip it. Type 2. This means that we fail to reject the null. So we cannot show change, which would mean that we would claim this person is innocent because the change is them being guilty. But they're actually guilty. And however much flack I'm going to get for this, the great example of this would be like O.J. Simpson, right? Where he would claim that he was innocent and everybody's aware he's guilty of this crime that he committed. Okay, so there will be more examples of type 1 and type 2 error in the examples for this chapter, and then I'll probably run through one more hypothesis test from each type here if you guys feel like you need that as well.